started. I did put a place for you to turn in section 2.7, I believe. Let me see. The extra credit section. All right. So I still got to build a place for 2.8. And we did do some 2.8 stuff last time, if I remember correctly. You guys are going to have to help me out a bit. Section 2.8 was the one about finding the average if things are weighted like they are in my class, where like the final's worth some percentage. I can't even remember off the top of my head. But does anyone have any questions from homework now that a few more people came in? Anybody? Does everybody remember what's happening this week on Thursday?
Yeah, we have our midterm.
Midterm. And how will it be taken?
In class, right? That'll be
in class, on camera. So you've known forever that the final and the midterm is going to be on camera. So hopefully, if you did have an issue, you would have worked it out with me by now about camera use and all that kind of stuff. Okay. So tomorrow, hopefully by the end of the day, I'll put a practice midterm up on Canvas. And then I think on Wednesday, it'll be kind of like review day on Wednesday, because Thursday's the midterm. It'll be in class. You won't have to take it after class. It'll be in class on camera. Yeah, so then I've got the spring break to grade it, and you got spring break to enjoy. I like it. Well, and work on chapter 3 homework, because we're going to get into chapter 3 this week. So no questions?
Professor?
Yes.
I have a question about the midterm. This is an awful question to ask, but the length, how long is the midterm? It's not, I'm just wondering for time's sake. Like,
it's not an awful question. It's a completely reasonable question. Yeah, because our class goes from 9 to 10:20. So it can't be like crazy long. So yeah, it's not going to be, it's going to be about as long. Well, let's see. I predict around maybe a total of at most 20 questions, counting A, B, C, D, E. Probably shorter than that.
So it'll be a multiple choice. It will be a multiple choice.
No.
Oh, I didn't think so. Okay.
Yeah. Two things. If you ever have a math teacher who does multiple choice and does like Scantron, they're not a math teacher. I don't know what they are. They are not a math teacher. Secondly, you never want me to make a multiple choice. Oh my God. I know how to make an evil multiple choice, and that's the only way I know how to make them. So yeah, yeah. If you think, yeah, anyway, I know, you're just asking. Anything else?
Open camera required?
Say again?
Open camera.
Yeah, camera has to be on.
Okay.
Yeah. So get ready. Clean up a little section of your room or something, or put a screen behind you or whatever the hell. My intent is not to try to pry into your personal life. My intent is to maintain the integrity of the test. Yeah. Anything else, guys? Any other questions about the midterm or homework stuff or anything? No? Okay. All right. If there are no questions, we're just going to get back into where we left off. I'm a little surprised, but you know, I'm optimistic. I'm hoping that no questions is good and not horrible. So let's see. Let's get back into section 2.8. Let me see. Now let me see. Let's do this. Let me get up on the board for a minute. I really want to make sure that I did. I'm pretty sure I discussed this last time, but I do it in the conversion chart. All right, wait a minute. Okay. All right. Can you be a little more specific? Do you want a conversion example? Do you want to Like here's the chart, 1.5. What does that mean? Sorry. This conversion chart. $2.5. Okay, 2.5, sure. All right, let me see. Do you have a specific question? Wait, let me get to 2.5. Here we go. I know you just chatted at me. Hold on. That one. Wait, all right. All right, you got to work with me. So I'm in section 2.5 right now. Did you have a specific problem you're having trouble with? Or did you just want general examples again? Or what exactly do you need help with, Sabrina? Do you understand what I'm saying? Do you have a specific question? Do you want a general example of conversions? You got to help me a little bit. The one with the glacier. Okay, all right. It's not in here then, right? It's not here. 2.4 is it? Yes, I believe I do. But I think conversions are back in. Here it is. Okay. All right, here's the glacier. Okay. So I think by now, most people have had a chance to at least look at this. So I'm a little bit better. I'm a little bit more okay with kind of doing this problem a little more. All right, give me a second. Set things up here. I don't need you. Come here. All right, so this is that glacier problem. Sound like some. Anyway, I'm not going to say what I was about to say. Something about climate change. That glacier problem, glaciers are large masses of ice, blah, 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 blah. They move really slow. So they move 203 millimeters per day. So right now, I've got 203 millimeters per day. And I want to convert that to inches per hour. Now, somebody help me out. How do I go? So I want to go from millimeters to what then?
Inches.
Yeah.
Well, yeah.
All right. Let's all take some turns here. Now, somebody else tell me, what's the connection between millimeters and inches? And you can look on page 192 if you need to. Or you can look at the work you did already if you already did this problem. What's the connection between millimeters and inches? Is there a middleman? Do you guys understand what I mean when I say
yeah, centimeters?
Centimeters, that's right. All right, I want to make sure everybody's with me because a lot of people had some trouble with this problem. So if I can go from millimeters to centimeters, I can go to inches. Because if you look at that chart back on page 192, 1 inch is 2.54 centimeters. All right. Is everybody with me so far? Oh, I lost somebody. Damn. And again, this is the step that people skip and then they get screwed up. They lose track of what they're doing. This is a great life lesson, right? Plan out the attack and then you can attack it much easier. You can follow the steps. So how do I go from millimeters? So what can I do? Let's see. How do I go from millimeters to centimeters? What method can I use? Somebody else who hasn't spoken yet. What method can I use to go from millimeters to centimeters?
Multiply to 10.
So multiply
To 10.
not to 10, but multiply by 10?
Yeah, by 10.
Yes,
Right.
yeah. So if I write down King Henry died Monday drinking chocolate milk, here's my millimeters, here's my centimeters. You got to be careful. So would I multiply or would I divide? Here's the problem. See, I mean, all right, everybody, I just see, it's okay. You don't have to turn your camera on, but it's driving me a little crazy. I'm going to see one of you, so I can only gauge one of your faces. Okay, thank you, Caitlin. I got two faces to look at now. So if you both go, what the shit, then I'll say, oh no, 3, 4. All right, look at that. I get 4 times as much information now. Thank you. All right. So do you guys remember King Henry? Right. Now I see a lot of you guys you don't have to do it the way that I told you. You could kind of just multiply or divide by so many tens, but then you can make a very easy mistake. So what does this tell me to do? The way I'm in millimeters right now. How do I go to centimeters? What am I going to do over here? How do I go to centimeters? Huh?
Do you divide by the conversion? I'm trying to think. I'm sorry.
That's all right. What does this mean? I just drew one arrow, one step here. One step. What the hell? Please remember how metric works. It's so beautiful. To go from millimeters to centimeters.
It's
I
10,
move the
right?
decimal.
You do one place.
I move the decimal back once. Bam. And
Yeah.
then now this is 20.3 centimeters. That's beautiful. Do you understand why the rest of the world is looking at America like, what the shit are you people doing? And this is specifically about metric. There's a lot of other things I could say that about, but the way that we do our units is insane. Look how easy that was. I moved the decimal back 1 and I changed the units. Right now, I really did you have to do it the way that I just did it? No. Is the way I just did it the easiest way? Shit, yes. All right. So now can I go from centimeters to inches? I did the first step. I accomplished this step, millimeters to centimeters. Now, how do I go from centimeters to inches? What am I going to put where?
Move the decimal once to the left.
Here. No. So be careful. This is our metric step. We already did it, right? We went from millimeter to centimeter. Now, how do I go from centimeter to inch? What connects those two?
Multiply to 2.54.
Yeah, because again, you're almost like I placed you out there to say the wrong way to do things. Where am I going to put the centimeters?
On the bottom.
The bottoms. Now just stay with me. If you have a little faith in this method, you're not going to have to guess about when to multiply or divide. The first step is units. Take care of your unit. You want centimeter to die. Get out of here, centimeter. We're in America, right? Sorry. So I put the centimeter down here so they die, and then I put the inch up here. Now, what number goes next to each of these? What's the conversion say? It says one of these is 2.54 of these. So what am I supposed to do with 2.54?
Cancel. Oh,
What am I supposed to do with 2.54? Multiply or divide?
divided by.
Divided by. See,
Divide.
I really want you to understand. So you are correct in the sense that conversions are almost always about dividing or multiplying. But sometimes we just sort of guess. And we're like, I got a 50-50 shot. No, don't do that shit, right? This grid will always make sure you're dividing when you're supposed to divide and you're multiplying when you're supposed to multiply. You do not have to guess. Now we want to get to inches per hour. The top is now inches. Yay. So now what do I want to attack? What's wrong still? What unit do I have is wrong still? I got rid of my centimeters. Made it
Inches.
inches. Sorry?
Inches.
What do I want the answer to be in?
You want to change the days to hours.
Yeah. No, it's just-
Day.
do you guys understand?
Day.
Yeah, I'm with you. Just want to make sure everybody's with me. How fast was it moving in inches per hour? We've got inches. We don't want to lose inches, right? Because that's what they want. But we got days right now too. So like everybody's saying right now, I gotta kill the days. Okay. I really want you guys to see this eliminates all guessing. All guessing is gone. And I just have to pay attention. I got the top to be what I want it to be. Now, how do I kill the days? Where do I put days?
At the top, we have to write down day.
I like it. And on the bottom, I'm going to put my hours. And of course, 1 day, 24 hours. Now, days is gone. Now, what units am I in now? Inches per hour. And what do I do with these numbers? What am I going to put in the calculator?
You would multiply the top row and then divide by the bottom row.
Sure, but I don't really have to multiply by 1, so I'm not going to. I just
Divided by 2.54, divided by 24.
Yeah, you just do exactly what it says. If it's on the bottom, you divide by it. The ones you can ignore, right? Ignore the ones because they're not going to change anything. Dividing by 1, multiplying by 1 doesn't do shit. That's why you can ignore them because we know it's not going to change anything. So some people are sort of guessing when to multiply, when to divide, and you're not guessing correctly. I would predict you to guess correctly about 50% of the time, right? So that's not a good result. Some of you guys are stopping too early. You didn't make it go all the way to hours. You stopped at inches per day. It wants inches per hour. So you have to pay attention to what the problem wants. And then you have to check and see, did I get to the units the problem wanted? I really desperately want everybody to understand that. Is that better? Are you guys?
Excuse me. Yeah, your way is better, but I have a question. 2.4 and 24, there are both are on the bottom. I
Sorry.
think we
Yes,
have
yes,
to.
that's right. That's right.
I think we have to multiply them or not.
All right. So I was sort of hoping to. You could multiply these together and then divide this by what you get. But that is what this does. This makes it so much simpler to think about. If the number's on the bottom, divide by it. These are both in the bottom, so they're both dividing, correct?
Okay, thank you.
You're welcome. Okay. In a way, you're correct, but it's harder to put in the calculator correctly for what you kind of want it to do. I really want that to make sense. This makes more sense conceptually, and it makes more sense putting it in the calculator. So it just wins. Oh, I got a question in the chat from somebody. Let me get the take of the class. This is not a vote. This is what do you think? Do you think you can use notes on the midterm? This is not a vote. This is a what do you believe?
Yes.
Of course you can't. I love it.
Dang
No,
it.
you cannot use
His
notes.
rest shot.
You can't use notes on a quiz either. I mean, quizzes are quizzes. They're not open notes. So hopefully nobody's doing that. You can't work together on quizzes, right? Can't work together on the midterm. You can't use notes on the midterm. Okay, I like it. I am going to provide you with the conversion chart, formulas like the volume formulas. Are you guys with me? So I am not saying you suddenly have to memorize everything we've done, but I will provide you with those things. You cannot use your own notes. Okay, good question though.
Professor, regarding the midterm, we can copy it as a printout, the quiz, the test, sorry.
Of course you can. You'll be able to.
Yeah, and we can show you before we start, right? Because in the printer in another room.
Yes, that's fine.
Okay, okay.
Okay. How's everybody with it? So then just throw that in the calculator. I almost don't care what the answer is anymore, but what's important is how to get to the answer. Throw that in the calculator and you got it. What do you guys get? Anybody get that?
A very gross number.
Oh, can you be more specific?
Yes. It was like 0.2350 onwards.
Is that what you get? I can't remember now. I thought it was
I got 0.23 3, 3,
Yeah.
3.
Yes.
It's not repeating, but 0, 0, 5, 2, 4, 9.
Yeah. But the first few decimals are threes, right?
Let
Yeah.
me try that
Mhm.
again. Maybe
Yeah,
I
try it
put
again.
it in.
All right. So let me know if anybody else has trouble getting 0.333, blah, blah, blah. Okay. So you just do exactly what it says. 20.3 divided by 2.54 divided by 25. I'm almost certain you just left a number out or something.
I know what I did wrong. I put in 34 instead of 24.
That'll do it.
I don't.
Well, that would be neat if we got 10 more hours in a day, but
Yeah, it's 0.33. It's still a gross number.
oh, a poor little number. All right. Okay. Anything else, guys, from any homework? The older it is, the more I'm okay to kind of do it. This isn't that old, but what the hell? We could do this problem. Okay. All right. And let me remind you guys about something. There's a decent amount of time built into this class for questions. That's part of the way this class is. I think I told you that guy a while back. I've devoted more time than we need to each chapter to build in time for questions. So never hesitate to ask questions because you're like, I don't want to slow the class down. Well, that's the point of the class is questions. So don't hesitate. Okay. I don't see anything else coming in. So let's get back. Nothing else. Okay, so let's get back to where we were. Holy shit. Where was I? Where's this? Oh, wow. I'm almost right where I want to be. I am right where I want to be. Holy shit. All right, so let's work on this problem. Oh, I was going to go on the board. That's right. I forgot. So we're in section 2A. Let me do something on the board. Just to remind you guys what we did last time. Can you guys actually remind me? We did discuss. Let me see. I'm almost certain we got to the point where I'm pretty sure we did this. Where if I gave you sure, okay. Well, let me stop for a minute. And I call these the weights. No, does that sound familiar to anybody? No, okay. All right, let's do this. Maybe I'll just redo my lecture. I'm pretty sure I did this, but does this look familiar? Didn't we do this last time? Let's see. Yes, okay. So we found the average of this by doing 2 1s and 3 2s and 4 3s. And it might not have been exactly these numbers, but right. And then divide by 10. And we did it this way. And then we were like, this would be 2/10, which is 20% is 1s and 30% is 2s. So the other way, so again, this is not meant to be a lecture. This is a reminder of a lecture we did last time. So if you weren't here last time, you can go watch the video. But this gets to the point where I have a data point of 1 and it happens 20% of the time. Does everybody see that? It happens twice out of 10 total. So that's 20% of the time the data is 1. 30% of the time the data is 2. 40% of the time the data is 3. And 10% of the time the data is 4. Okay. Not a big deal, correct? Shouldn't be a big deal. But if I'm not given the data in a list and I'm given the data like this, I can very quickly figure out the average by doing this times this. I multiply the weight times the data point. The weight times the data point. Weight, data point, weight, data point. And then I add these. That is equivalent to doing this 20% times 1, 30% times 2, 40% times 3, 10% times 4, and then add them up. It's the same math happening. And again, we went over this more in depth last time. I just want to remind everybody where we kind of left off. I can't remember the way the book does it. We'll see in a minute, but this is officially, if you take statistics, this is the way you'll see this. A bunch of data points, the percentage or the probability of those data points. And then this is multiplying those. So what's the mean? The mean would be the sum of these. So 0.21, this is 0.8, 2.4, looks to be 2.4 if you add all these up. All right, let me stop for a minute. That's kind of beautiful. Multiply across, add down, bam. Okay, I like it. Can you guys take a quick hot minute and just find the average of these? Can you guys just add these all up, divide by 10? Go, do it. Find the average of these numbers. These numbers I've crossed out, poor little crossed out numbers. Find the average. I just keep using the word mean. I don't know if we've used that.
0.6.
How did you do that?
I add all of them and divide it by 4.
Okay, why did you divide by 4 when there's 10 data points?
Because
Did you do the X times P of X instead of the top
yeah,
set of numbers?
I
Oh,
want you to find the average of these
those.
numbers.
we have to add them.
Yes. You have to add these numbers. I
And
think
divide
you're
it
doing
by
like
numbers.
Christian said, I think, sorry?
Yeah, you're right.
So don't look at this. I just want to find the average of these. Like normal. Just find the average.
It's same of that one.
Yeah, I think Guillermo, I think you did a couple things, like you didn't divide by 10 and you also kind of added weird. I don't know how you get 20.4.
Is it 4.8?
How do you find the average? I love you guys so much. This is not a problem. This is just find the average of these numbers. You add them up.
All together and divided by 10 is
Exactly.
same number.
Of course, yeah. So that's the point I'm trying to make, is if I do this the old way, if I add them all up, I get 2, 4, 6, 8, 12, 12, 24, right? When I add them all up, I get 24. And when I divide by how many there are, I get 2.4, which of course is the same number. This does the same math that we just did. It just does it in a little bit different order. Okay. So some of you guys might then say, well, what the shit do we do things like this for when I could just do it like that, Jeff? Well, all right, let me show you. Okay. And do you see how, if I see that could mean 2 1s, 3 2s, 4 3s, and 1 4, right? Just like we had up here, correct? So then I could just write a big list out and do it the old way, but now watch. What if I had data like this? Oh boy, here's where things get interesting. All right, we can do it, Jeff. Oh shit, what's that? Let's see. It's 61%. Oh, really? All right, sure. I think that's right. 33. So what am I trying to be careful about when I'm creating this? Since these are percentages, what do they all have to add up to be?
100.
100, so that I know I have all my data, right? I've got to add up to be 100% of all my data. So look, watch. You could make a list out of this, but then I would have to have 9 5s, 24 9s, 37. Do you want to write that list? Shit, no, right? I don't want to. All right, 9 5s. This is good so far. So I'd much rather just go ahead and multiply across, right? Multiply across and then add down. Do it. I'll sit here and wait and do nothing. All right, let me try to catch up to you. I might need some help. Is this 2.16?
16.
I don't know what that is. What is that?
4.44.
Neato. And then this bad boy, 5.1?
5.1.
So that was relatively easy, right? Just multiply across, multiply the data point by the weight. So this tells me the contribution to the mean from this, the contribution to the mean from this. So when I add them all up, I make the mean, the average. I keep using the word mean, but mean means average. I can't remember if we talked about that. So what do you get when you add all these up? 12.25? I did that too fast.
12.15.
12.15? Okay. I
Yeah.
lost. I had an extra 1 somewhere. And real quick, guys, can anyone tell, let me see if you guys understand this question. What's the most heaviest weighted data point? What's the data point that has the heaviest weight? Where are the weights at?
0.37.
Yeah, so 12 is the heaviest weighted. 17 is the next heaviest weighted. And then these are lighter, right? So does it make sense the average came out to be around here? Yes, because that's the heaviest weighted thing. It should bring the average towards it. I don't know if you guys are with me at all. This is sort of like astronomy at the same time. We're sort of talking about astronomical things attracting each other. Okay, maybe. So that's why this is beautiful to call these weights, because it's a really nice visual idea. This is going to pull the average towards it. Bam. So if I would have made that the heaviest weighted thing, the average would have been much lower. Okay. All right. Now. Let's go back to the book and let's do some examples. All right, you guys go over there. So here is a hypothetical class. Don't look at all this little bullshit here. So 20% homework, 20% group and class participation, 40% unit exams, and 20% final exam. Okay. There's the grading scale. All right. So they tell you for this person, Christine, how she did. So just let's do this first one together. Can somebody tell me, how would you get the average that she got on the homework? On the homework by itself, just what's her homework grade? What did she get on the homework?
22?
Sorry?
You got
72?
200.
220. She got 220 points out of how many total possible points?
We need to find out the percentage she got on the homework, right? She got 220 out of 320 points. So
There you go.
first,
So what's
first
that
and-
percentage?
69%.
All right, and let's be careful. It's definitely not 68%. 69% I would be better with, but let's be more specific.
68.75%.
Now let me stop for a minute. Please tell me if you're not able to get that. Does everybody see how we got that?
That's actually what I got was 68.75.
I'm with you. I figured that was it. But you always got to be careful. You know, very few times will you ever just cut a number besides round it. Okay. Anybody not see where we got that from? We could all be insane. Caitlin and the other people that said this, Tristan and me, we could all be insane. So let me know if you don't know where we got that from. All we did was do 220 divided by 320. Of course, that's going to be what the percentage she got on the homework. So let's write that down. So now I just want you to finish filling this in. Become a normal 6. All right, that's fine. He's got a strong chin. That's 6. Now fill in the rest of these. Go ahead, fill in the rest of these. Oh. Oh, okay. Somebody's telling me the answers. I don't know yet. You got to be careful on the unit exams. You want to get all of them together. Oh. Yeah, I'm with you. So what did somebody get for group work? I got one person telling me in the chat what it is. What did you guys get for group work?
I got 89.
Yeah,
Yeah,
might as well miss-
89%.
yeah, we could just make it 89 because it's like 0.0 something. So it's 0.02. So it's like, we'll just make it 89. That's fine. Now to do the unit exams, you should really, you got to be careful how you do this. I'm very curious how you guys are going to do this. You could actually just find the average of those. That's fine. Or you could do, okay, I got one person telling me what it is.
.75%.
Yes.
Okay.
So there's two main ways you can do that. Oops, shit. Get these out of here. You could just do 77 plus 82 plus 71 plus 85 because they're all out of 100, right? So you could just do 77 plus 82 plus 71 plus 85 divided by 4. Or you could say it's out of 400 total points, 77 plus 82 plus 71 plus 85 divided by 400, which will give you a decimal. I don't know if you guys are cool with the fact that I just did the same thing twice. Math allows you to do some things in different orders. I don't know if you guys are with me. Oh, you got to be careful. I see. So I already forgot what we just said. Shit, 78.75, right? 78.75, I like it. And then the final exam is pretty straightforward. What do you guys get for the final? I got one person that chatted to me. What do you guys get for the final?
I don't know if it's right, but I got 81.
Yep, beautiful.
Oh.
You just do 162 divided by 200. Of course, right? That's exactly what it says. So you get 81. I like it. Let me see. So tell me, this is obviously wrong, especially the way I'm saying this, but I mean, what is wrong if I just average these to find this person's grade? What is wrong if I just average these numbers?
Because all are not same percentage.
Yeah, they're not all equally weighted. I love it. What's the heaviest weighted thing? Of course,
Unit exam.
yes, that's 40% for that, right? And everything else is 20, right? I kind of chopped this guy off, 20, 40, 60. Yes, everything else is 20%. So now I fill in the weights. So this will be this, the unit exam is 0.4 and the rest of them are 0.2. Does everybody see where I'm getting those numbers from? All right. I kind of had that top one off the screen, but oh well. So I got my grades in each category. I got the weight of each category. So now how do I create this last column? What do I do?
Multiply.
Multiply across. I love it. Okay, so I'm just sort of gonna fill these in as I go. Holy crap. I love my pen sometimes. Hold on. Help me. Okay. So I got for this one 13.75. I got 17.8 for this one. Somebody already gave me the answer to the unit exams, I think.
31.5.
Yeah. And then finally, the final.
16.2.
Good. All right. So then to find the average, you just add all those up. It's kind of neat. I really want this to make, so this little tiny bit is the contribution to the average from the homework. And then this is the contribution to the average for the group work. And this is the contribution to the average for the unit, blah, 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 blah. So you can see the biggest contributor is this guy because he was the heaviest weighted thing. That makes sense. So the higher this grade is, the better for the student. It happens to be the second lowest grade, but we'll see. How do they come out? So what do you do with these now? Oop. Sounds about right. So I just add these up here, right?
Add together divided by 4.
No, definitely not. Definitely not divided by
Okay.
4. And I want you to really understand why. The divided by business is already built in here. Those are percentages. Aren't percentages divided by something? So that would make
So
no sense.
divided by 400.
No. The division has already taken place through the weights that we put down because those are percentages. So the division that you're wanting to do has already taken place. I just add these up and that's it. I just add those up. Okay. Because remember, that's the point I was trying to make with the work we did up here. I could either add and then divide, or I can divide first, which is what I'm doing here when I make these weights, and then add. So I've already divided. All I got to do now is add. So I think a few people have told me what the answer is, but now I've forgotten where this was. Okay. So do you get 79.25? when you add those up? Yeah, okay, so a few people have told me. Is everybody cool with that? You can get 79.25. Now, I really, if you divided that by 4, you're going to get 19 point something. Would that make any sense to say that a student who got these grades has an average of 19 point something? Would that make sense? Do you understand what I'm asking? Would that make sense? I'm sort of giving the answer away in the way I'm saying it, but of course it wouldn't, right? You're not going to tell this kid. I mean, if I told this kid he's got these grades and I'm like, hey, you got about a 19, he's going to be saying, you teach what again? I can't have a 19 average if I made these grades. There's no way. The average should be in the middle of all these grades somehow. Now, why is the average really close to this grade? And it doesn't always have to be this way, but I would expect the average to be most affected by this grade because it is the heaviest weighted thing. I like it. So I really want you to, the point I was trying to make with the work we did on the board earlier was I could divide last or I could divide first. So here we're just dividing first. When we multiply by the probabilities, by the percentages, the division's built in. That's why I don't have to divide at the end. Okay, maybe. All right. So you guys help me out. Keep track of this. I've got to delete this so I can scroll down a bit. I'm going to clear all these away. You guys ready? Here it goes. Bye. Blah, 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 blah. Okay, this is all just, so what letter grade did Christine earn? What letter grade does she get?
Let's see.
Let's see.
Yeah, doesn't that suck? Can you understand Jeff's frustration? So let's say that there's another kid, another person who gets a 70.3. They're going to get a C, right? Christine got a 79.25. She also gets a C. Does that seem fair? In my grading scale, she gets a plus at least, right? All right, so that's a little bit better. It always killed me to give the 80 student the same exact grade as the 89 student, and so happy we got pluses and minuses now. Yay. Okay, I have no idea how you feel about it, and it doesn't matter because it's just the best way to do it. All right. So I'm going to clear that away. Put the bow. Blah, 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 blah. Okay. Do this real quick. Go ahead and do this one. This number 3. Did you get it? Let's see if you got it. They've already got it all filled in for you. That kicks so much ass.
$80. The grade is gonna be 80.
All right, let's see. You guys keep going. You never know. You could have made a mistake. So if I do, I multiply these and then I add these. So 70 times 0.2 is 14. 75 times 0.3 is something. 22.5. Is that right?
Yes.
And then 87 times 0.5 is 43.5. What is it? 43.5, right? Got 80. Okay. So when I add those up, I get 60, 70, 79, 80. So student got an 80. I like it. Real quick. What's the average? All right, I really want you guys to understand. So I'm going to ask a different question. What if I didn't have all these weights? What if I just average these numbers? What do you get when you average those numbers directly? Just average those. So average these numbers. What do you get?
$77.33.
Ooh, I like it. So yes, 77.33.
Yes.
So why is the actual grade higher than the average we just got? Ah, crap. I lost the actual grade. I lost everything. Why is the actual grade higher than just the straight up average of those? You can do it.
Because of the heaviest weight in 87.
Yes, the heaviest weighted thing is the highest grade. Since it's got a little bit more weight to it, it's going to pull the average up higher, closer to it. So if I just average these directly, that's this. That's if everything was equally weighted, that's the grade that person would have. That would be a C. But if I use the actual weights, they actually get a B. Now, do you guys remember what's weird on my syllabus? How I do the weights? Does anyone remember what's weird about how I do the weights of categories? I can show you. Let me see. I'm going to erase this. I'm going to go away from this. Here it goes. Bam. Okay. Let me remind you guys something most interesting about freaky ass Jeff and his weird ways of doing things. How heavily weighted is the final exam?
$25 to or 30%.
Yeah. How heavily weighted is the quiz? So that I don't have a set weight. So what I do is, I don't quite do exactly this, but it accomplishes. I just calculate all the different ways and I give you the highest way. Do you understand? Yes. I don't know if you guys remember, we talked about that before because these are kind of arbitrary to a certain degree. So I sort of gave a range that I was comfortable with. I calculated every different way and I give you the highest one. You're welcome. Right. Okay. All right. So I kind of adjust my my weighted assignment because I kind of realized this is about 12 years ago now. I was like, whoa, what if I pick this? But if I would have picked this, then there's a student that would have passed, but they failed just because I happened to pick this other thing. That seemed very kind of evil to me. So I just go ahead and pick all the ways. All right. Blah, 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 blah. Let me see. Where do we leave off? Here we go. Now here's something really neat. All right. How do I say this? Where am I at? Oh, good. Yeah. Do you see how right now the student, this is before the final exam. So we don't know what the final score is. So I'm going to give you a way to figure out what your average is, even if you don't know something else. I actually calculate this for you, but I just want you to know how I do it. So go ahead and fill in as much as you can in the table. Do you understand the final? Are you going to put a 0 here? Would you want to do? Hell no. You don't put shit here. So this row stays empty because I don't know. There is a way to figure out what your grade is so far. Look. Oh, well, no, be careful. You can't get an overall grade yet because we have a missing category. So all you can do is fill in these 3 spots. Don't do anything else. I really, obvious. Hopefully you guys understand that adding those up would be really evil because I'm missing information. I don't know this. So of course here I get 9.5. Is that cool so far? 9.5. Then I get, I don't know, 13.2. Is that right? Woohoo, Jeff. And then I get, you know this, Jeff, 44.5. All right. So don't, now really stay with me. Really stay with me. Really stay with me. Obviously, I'm not going to add those up. That doesn't mean shit. That if I add those up, what is that assuming about the final? If I add up what I got so far, what is that assuming about the final? You can do it. If I just add these up right now, what am I assuming is here?
0.
0. So you're assuming you got a 0 on the final. So that's this question. If you don't show up for the final, what would be your final grade? It would be adding these up. And if you add those up, what do you get? I think you get 63.2. No, I don't know. 67.2. Is that right?
67.2, yeah.
60. Okay. Yeah, I agree with you. So that's what you would get. Let me put it down here. You would get a 67.2 if you didn't show up for the final. Okay, that would be stupid. But how do you tell? All right, here's a really good question. How do you know what you've gotten so far? What is your current grade? It's not this. Is everybody agree with me? That cannot be your current grade. You wouldn't look at those grades and say, oh yeah, you got a 67 right now. Right? Are you with me? All right. So how the shit do you do it? Okay, what you do is you do this. This is kind of cool. You take 67.2 divided by what percentage of my grade do I know so far? I don't know this much, right? This is unknown. I don't know this. I don't know 25%. So what percentage do I know? Obviously what? If I don't know 25%, I do know how much of my grade.
75%.
75%. So here's what's kind of freaky. You divide what you know so far by 0.75.
89.6.
So your actual current average is an 89.6. And the reason this works, all right, I don't know if you guys are going to go with me on this. This is kind of a neat thing. Wouldn't you say that the 67.2 is what percent of your overall grade? 75% of your overall grade, right? Isn't the 67.2 represent 75% of what your grade is going to be? All right, this is a little freaky. I don't know if you guys are going to stay with me. Some of you guys have already checked out. I don't, well, that's a bad idea in general. But isn't 67.2, isn't that equal to 75% of your actual grade right now?
Yeah, it makes total sense now that you explain it like that. Yeah.
And then I would divide by 75% and I would be left with my actual grade right now. So that's why I divide what I have so far total divided by what the percentage total is for that. Okay, that's really weird, I know. But that's actually how I calculate where somebody stands in the class up to a certain point. I just have to divide by the total weight of stuff we've done so far. And 89.6, does that make sense? Looking at the grades, 89.6, and considering this is the highest weighted thing. Yeah, that makes sense. I'm not going to tell this kid 67.2. Damn, that would be evil. All right, maybe. So these are all cool kind of behind the scenes stuff about how grades work with these grading scales that you've all seen forever, right? Okay, let me clear all this away. Clear. Okay. Oh, all right. Now, this is where we're getting, okay. So I keep calling these percentages and probabilities. Now with grades, there's no probability. It's a percentage. But here's a complete probability. Okay, now stay with me. This is such a cool thing. This little setup, these what do you call it? You could do it, Jeff. These columns that we set up. Hold on, let me pull this up a little bit. Okay, that should be good. Works no matter if the weights are percentages or probabilities. So there are so many instances in this universe, in this world, where you want to figure out, does it look more like you'll gain money or does it look more like you'll lose money? Doesn't that make sense? If you have an investment opportunity, don't you want to know, is it likely you'll make money or likely you'll lose money? So let me ask you this, guys. Let me actually do this. Bam. Look at me. You look at me now. If I said, pay me $1, and if you roll this die, if you get a 1, I'll give you $2. Would anyone play that game? So you give me $1, you take the die, you roll it, and if you get a 1, I'll give you $2. What does your gut tell you? Do you think that's a good game to play?
No, but what's the point of gambling, right?
Well, we're getting to that. All right, stay with me now. Do you guys kind of agree with that? It depends on how big of a gambler you are, I guess. But in general, that would be not a good game to play. If you had to pay $1 and you get anything except a 1, you don't get shit. You just out $1. But if you get a 1, I'll give you $2. Now listen. If there was an opportunity, if somebody's like, give me $1, if you roll a 1, I will give you $1 million. Would you play that game? If you can verify a real million, right? For sure, you're going to get $1 million.
Yes.
Hell yeah, you wouldn't even think twice about it. Like, shit, yeah, I'm going to roll that thing a few times. I mean, it's so there's a combination of things. There's the amount you could gain and the probability of you getting that amount. Are you with me? So if the probability of winning is high, the amount you get almost doesn't matter. Do you understand what I'm saying? But if the amount that you could win is low, then the probability you win has to be high. So it's kind of a give and take. Now, help me out with this. Let's do this first. So let's see. In a classic car, you have to pay $2 to spin the wheel. If it lands on red, you get $3. So let me ask you this. If you had to pay $2 and you land on red and you get $3, how much money did you actually just make?
$1.
$1.
One.
So you see right here, that's where the $1 came from. Are you with me? Red, you get $1. If it lands on yellow, you get your $2 back, basically, right? So that's why it's 0 here.
Professor,
Yes.
I don't think we can see the
Oh,
screen.
shit. I'm sorry.
There's-
I always do that. I had you looking at me and then, all right, let's come back here. All right. All right. So if you land on red, you get $3, but you had to pay $2. So that's a gain of $1. You would have profited $1. If you land on yellow, you get a spin again. So it's like $0. If it lands on purple, you just lose $2. Too bad for you. Right? You lose $2. And if it lands on blue, you get paid $5. So of course, what am I going to put here? Careful, I'm not going to put 5. If it lands on blue, I get
Minus
$5.
5.
Say
Minus
again.
5.
No.
3.
3. Exactly. Why 3? How much did I have to pay to play? I had to pay $2 to play. So if they give me $5, that means I actually just made $3. Let me stop for a minute. Are you guys all with me? Trishan, what's going on? You're loving this.
I had gotten a message. I'm sorry, I wasn't laughing at your thing. I'm
That's
so
fine.
sorry.
That's fine. It's okay. All right. Is everybody with me here? Obviously, if you have to pay $2 and then they give you $5, you didn't just make $5, you made $3. Please let that make sense. Okay. Now looking at this, assuming this is actually set up correctly, which is a huge assumption. If you just see some dude on a street corner with this, you don't really see this grift too much, but assuming this is set up in a fair way, can somebody tell me what the probability is I'll land on red? What's the probability that I'll land on red? How many red spots are there?
There's 2 and there's 8 spaces, right?
Yes. So what's 2 out of 8?
25%.
There we go. So 0.25. I like it. Now finish that out. Fill in the other probabilities for me. Fill in the yellow probability. Fill this in. Fill this column here in. Once you get going, it's pretty simple, I think, right? What about for yellow? Isn't yellow the same?
Yes.
Because there's 2 yellows out of 8, so that's another 0.25. What about purple?
3 divided by 8.
Good.
It's a 37.5%.
I like what I just did. I had a double decimal. It's neat. All right. And then blue, well, that makes sense. Purple is the highest probability because that's where you lose the most. And blue is the lowest probability because that's where you win the most. That sounds like Vegas. So what is 1/8, of course, would be?
Well, 125.
Now, what can you do right now to make sure everything looks good? What are these all supposed to add to be? If I add up all the probabilities in a problem, what should they always add up to be?
100?
100%, or 1 if they're all decimals, right? And sure enough, if you add these up, they will come out to be 1. That's a great check to make sure you're on the right track. If they don't add up to 1 or 100%, if you have them in percentages, you left somebody out or something weird happened. All right, so now, you see what they say here? Expected value, that's another name for the average. This is what I can expect to make on each game if I play this game a lot. So it's sort of like a way to gauge, is it worth it to gamble on this or not? So it kind of takes into account the amounts and the probabilities. And remember, I said, if the probability of winning is high, then the amount you win could be low and it could still, or if the probability you win is low, then the amount you win better be high to make it worth it. So that's why this kind of makes sense. I want to take those into account, both of them. So I do the same thing we did before. I multiply across and I add down, which is what they're showing me here. I multiply the x's times the p of x's. So 1 times 0.25 is 0.25. 0 times 0.25 is 0, right? -2 times 0.375 is negative 0.75. Is that right? I think so. And then 3 times 0.125 is, I don't know. Is that 0.3? Yeah, it's 0.375.
And Professor, I have a question.
Yes.
What's the difference between yellow and purple?
What do you mean the difference between? So here's yellow.
If the arrow comes in the yellow, I lose the $2, and if they coming in the purple, I lose $2 too.
No. If it lands on yellow, you don't have to pay basically. So you didn't lose $2. It's 0.
But I didn't pay at the beginning $2.
Yes, you
this
did.
game.
Yes.
Yes.
So basically,
Oh,
if you
okay,
land on
okay.
yellow,
That
you
means
get
I
another
lose
spin.
$4 in the variable.
No, you don't.
The $2 at the beginning and $2 after that, right?
What's happening? So if you land on purple, you're out the $2. You're out the $2 that you paid. You just lose those $2.
Okay,
That's it. Not you lose an additional $2.
okay.
So-
And yellow?
Yellow means it's a spin again, which means you basically don't have to pay $2 for another spin, which means a net gain of $0.
Oh, okay, okay.
Okay. All right, I like it. So what does this add up to be, this last column here? I think it's negative 0.125, is that right? Can anyone help me out?
Yes.
Okay, so what this means, what do you think that means? The fact that it came out negative, do you think that's good or bad?
Bad.
That's bad. What this means is, if I play this game a lot, I can expect to lose about 13 cents on average each time I play. So if I play, so I would lose this much money per game on average. So if I played 100 times, I could expect to lose $125. No, Jeff, you could do it. Negative 12.50. There you go. Just move it twice. I could lose $12.50. On average, I would lose that much. If the expected value comes out negative, that means you can expect money to go away from you. So the negative is kind of like a loss, cash flow away. If it's positive, you can expect over the long run cash to come towards you, positive flow, income instead of outcome. Income instead of outgo. There it is. Maybe this is how business people can assess, should we do this investment? Should we partner with this company? They can kind of analyze, well, here's the probability that this happens. Here's probably this happens, and this is what it means for our investment. And then they can do this table, and they can figure out if it's positive, we should do it. If it's negative, we maybe shouldn't do it. So what this means for the person running this is they expect to make this much money on average. So if they have 100 people come by and play this game, they can expect to gain $12.50 off of them. Will they always gain exactly that much? No, but that's how much it will average out to be. So here's the intersection of probabilities with outcomes. And you're seeing how I can analyze what to expect to happen. Does it mean it will definitely happen? No. Does it mean it will likely happen? Yes. This is the likely outcome. Could somebody play this game 3 times and win a bunch of money? Sure. Right? Okay, I love you guys. So people don't understand probability. Probability is if I do something a lot, what can expect to happen? That's what probability really is. Whoo. Okay. So I want you to appreciate that. Even if these percentages mean percentages, like the weights for grades, I do the same math. If they mean probabilities, I do the same math. Because probabilities are basically a type of percentage. All right. I think that might be a good place to stop for today. That's kind of a lot. But all right. So hopefully later today, I'll have the practice midterm up. And then Wednesday, we'll talk about it. I'll put the answer key up by Wednesday. And then Thursday's a midterm. All right. So let me know if you need to hang out. Otherwise, you are free to go.
Thank you so much, Professor. Just give me a heads up one more time that I won't be here tomorrow. So
Okay.
I'll see you on Wednesday.
All right. Thanks, Trish.
Thank you, Professor.
Sure. Everybody else good? All right. I'm going to head out. See you guys.